Newton's third law of motion tells us that when you push a thing, the thing pushes back. In this lesson, we'll talk about what Newton's third law of motion says, and we'll look into action-reaction force pairs. Newton's third law of motion says that for every action, there's an equal and opposite reaction. Now, when we say equal and opposite, we mean equal in size and opposite in direction. In other words, for every action, there's an equally sized but opposite direction reaction. Let's look at some action-reaction force pairs. If you were to push on a wall, you would put a force on the wall, but the wall is putting an equal and opposite force back onto your shoulder. When a baseball player swings a bat and hits a ball, the ball is putting a force onto the bat, just like the bat is putting a force onto the ball. If you've ever played baseball, you've probably felt that force in your hands when you connect with the ball. Another action-reaction force pair happens when something sits on a table. Gravity is causing the book to put a downward force onto the table, but at the same time, the table is putting an upward force onto the book. Remember that the force of gravity is called Fg, and the upward force from the table is called the normal force, or Fn. If you've ever blown up a balloon and let it go to fly around the room, you've used an action-reaction force pair to make the balloon fly. The action of the air forcing its way out the back of the balloon applies a reaction force to the front of the balloon that makes it fly. A common misperception about action-reaction force pairs is that they cancel each other out because they're equal in size and opposite in direction. This isn't true because the action force and the reaction force act on different objects. In this example, the hammer is applying an action force to the nail, but the nail applies a reaction force back to the hammer. They're equal in size in opposite directions, but they apply to different objects. In this lesson, we looked at Newton's third law, which says that for every action, there's an equal and opposite reaction. We looked at how forces come in action-reaction pairs, which are equal in size but opposite in direction.